Alright, well we have one more type of factoring to look at, and it's called the difference of perfect squares, and this is a special case. If you recall from last unit, if I gave you something where it was x plus 2 times x minus 2, where I had the exact same thing in my binomials, except for the fact that you were adding in one and subtracting the other, what happened was you would multiply your first terms to get x squared, you would multiply your outside to get minus 2x, you would multiply your inside to get plus 2x, and then you would multiply your last to get minus 4. And then what always ended up happening was in here, these two things would be exactly the same, so they would cancel out, which would leave me with x squared minus 4. This x squared minus 4, this is what we call the difference of perfect squares. Well, where that comes from is the fact that this is minus, so I'm taking a difference. X squared is a perfect square, and 4 is a perfect square. Well, x squared, the perfect square, the square root of x squared is x. So in my binomials, I had an x and an x. And then the square root of 4 was 2. So in my binomials, I have a 2 and a 2. But then there's a plus and a minus. So we want to keep that into consideration for the type of examples we're going to get. So what we have to do is we have to check and make sure our two terms are actually perfect squares. We have to check and make sure that we're subtracting. And when that happens, we have to take our two things and find the square roots. So what I mean by that is, for example, if I have 4x squared minus 121, I have to check a couple things. Number one, I have to check and make sure it's a difference. Well, yes, it's a difference. The next thing I have to check is the fact that my two terms are actually perfect squares. So I want to check 4x squared, and I want to check 121. 4x squared is my thing 1. So my thing 1 is 4x squared. And I want to check and make sure I can take the square root of that. Well, the square root of 4 is 2. The square root of x squared is x, because x times x gives me x squared. Now I want to look at thing 2, which is 121. So thing 2 is 121, and I want to take the square root of that, which is 11. Alright, so these were two perfect squares. So just like happened in my example where I originally multiplied it out, your two binomials have to be adding and they have to be subtracting. So you're going to take your two things, so you're going to take 2x and 11, and you're going to do thing 1 plus thing 2, and thing 1 minus thing 2. So your final answer would be 2x minus 11 times 2x plus 11. Alright, let's look at another example. Alright, again, for example, I could have negative 100 plus x squared. Alright, and you're going to say, but wait, that's not a difference. Negative 100 plus x squared is not subtracting, it's adding. Well, I can easily just go in and switch around the order. So instead of having negative 100 plus x squared, I actually can switch that to x squared minus 100. Alright, then again, I want to go in and find thing 1 and thing 2. Thing 1 is x squared, and thing 2 is 100. Then I want to go in and take the square root of both of those. Well, the square root of x squared is just x. The square root of 100 is 10. So I'm going to take those two things and I'm going to add them together and I'm going to subtract them, making sure I do thing 1 and then thing 2. So I have x plus 10 times x minus 10. And that would be my final answer.